In this video, I'm going to show you how to solve quartic equations for x. So a quartic equation is one that the highest power is 4, which in this case it is. So basically we can solve these really similar to how we would solve a quadratic. And so in this case, we're going to factor. But the big thing when we're factoring quadratics is this first term in each binomial has to multiply to get our first term in our equation. So in this case, x and x don't multiply to x to the fourth, but x squared and x squared do multiply to x to the fourth. Now the rest of the rules are the same. We want something that multiplies to negative 12 and adds to negative 1. So our c and b terms. And our factors of 12, of course, are 1 and 12, 2 and 6, 3 and 4. And 3 and 4 will work, except for this is a negative 12. Looks like they need to add to negative 1, so the 4 needs to be negative in this case. It doesn't really matter what order we put these in. We're going to set these both equal to 0 and solve. So x squared minus 4 equals 0. X squared plus 3 equals 0. X squared minus 4, we can add the 4 over. You could also notice that this one is a difference of squares and just factor it. But in this case, we'll take a square root, of course, with our plinus in there, so x equals plus or minus 2. And over here for our 3, x squared equals negative 3. Take a square root on both sides, the plinus. And when we take a square root of a negative, it turns into an I. So in this case, x would equal plus or minus I squared of 3. And those are our 4 answers for this problem. This problem is going to be very similar. We are still factoring. So let's go ahead and factor this. If you want to pause the video and take a second to try this one on your own, you can certainly do that. Okay, we're going to start factoring just with our x squareds. Now what multiplies to 2 and adds to negative 3? Well, negative 1 and negative 2. So x squared minus 2 equals 0. X squared minus 1 equals 0. This time I'm going to factor that x squared minus 1 because I know it's a difference of squares. So x plus 1, x minus 1 equals 0. Here x equals plus or minus 1. On the left side, we'll add 2. Square root both sides. X equals plus or minus square root of 2. And those are our 4 answers for this one. Again, remember you have to have 4 answers because this is a quartic equation. I shouldn't say you have to have 4. You might have 3. In these cases where we're factoring, you should end up with 4. All right. If we're looking right away at factoring this, you can see there's nothing that adds to negative 2, or sorry, that multiplies to negative 2 and adds to 4. No factors there. So we're actually going to back up and not factor this. We're going to use the quadratic equation. Now you might say, this is a quartic equation, we can't use the quadratic equation. But we still can in the same way that we were factoring, just like we would a quadratic. But this time it's going to be, instead of x equals for a quadratic equation, we're going to use x squared equals. And the same rules apply like our a term, b term, and c term here. So negative b plus or minus square root b squared minus 4ac. In this case, our a term is 1, so I'm not even going to write it in there. Divided by 2a. Okay, let's simplify. Remember, bring your x squared down because we're going to have to take a square root at the end. Negative 4 plus or minus 16 plus 8 is the square root of 24. Divide by 2, simplify that square root. 4 is our perfect square that goes into 24. So negative 4 plus or minus, oh, my mistake. Should be the square root of 4 times the square root of 6, which ends up being 2 square root of 6. And divide by 2, let's simplify. We can divide negative 4 plus or minus 2 and the 2 all by 2. So x squared equals negative 2 plus or minus square root of 6. And now to solve for x, we need to take a square root on both sides. And of course, it's plus or minus. So x equals plus or minus the square root of negative 2 plus or minus square root of 6. Now this looks a little scary that we have a square root inside of a square root, but it works. And you can plug this in your calculator to get a decimal, but we want an exact answer, and that's why we're using square roots in this case. So there is our answer. All right, let's do one more problem here. Does this one factor? Well, it might. Let's try it out. You can always use the quadratic formula, but of course we found out that the quadratic formula can kind of get, I don't want to say, it just gets like to be a lot of work. So let's try factoring this first. Factors of 3 are 3 and 1, so we'll go 3x squared and x squared. And now we want something, our other factor has to be factors of 5, which thankfully we only have 2 factors, right? 1 and 5. But what order are these going to go in here? Well, let's just try one and see if it works. We put a 1 and a 5. Well, one's got to be positive, one negative. If I multiply my outside, which is 3 and 5, I get 15. And then I multiply the inside, I get 1. Well, I'd have to subtract, let's see, I'd have to subtract 15 from 1, right? So a positive 1 and a minus 15 or negative 15 to get this negative 14 in here. All right, if you've been in my classroom, you know that we've done quite a bit of work on these, so I'm not going to explain that anymore. Okay, let's set these both equal to solve. Okay, set them both equal to 0. This first one here, x squared equals negative 1/3. Take a square root of both sides. X equals plus or minus I square root of 1/3. And I know we have talked quite a bit about how this isn't in proper form. We don't want a square root on the bottom. So this really is the same as the square root of 1 over the square root of 3. Okay, well, we need to multiply the square root of 3 on the top and on the bottom to get rid of that. So x equals plus or minus I, well, the top would be square root of 3, bottom is 3. So there's half of our answer. And let's solve this other one. X squared equals 5, square root of both sides. X equals plus or minus the square root of 5. And those are our 4 answers in this case. Remember, like and follow for more math videos.